So in this lecture, we want to calculate how much work is done on a spring when we compress and stretch that spring. So let's begin. A person compresses a spring a distance of 5 centimeters, which requires a maximum force of 100 newtons. Now, A, how much work does the person do? And B, how much work is done if the person instead stretches the spring by 7 centimeters? So, in both cases, we want to find the work. And in order to find the work, we must know the spring constant. Notice in the stem of the question, we're not given the spring constant K. But we do know that if we apply a maximum force of 100 newtons on the spring, we will displace the spring a distance of 5 centimeters. So equivalently, that means it will displace a distance of 0.05 meters. So our displacement or change in position is 0.05 meters. The maximum force is 100 newtons. So we can use Hooke's law to calculate the spring constant K. So 100 newtons is equal to K times our displacement. So we divide by displacement and we get that our K, the spring constant, the stiffness in the spring, is equal to 2000 newtons per meter. So now we use our equation for the work done on our spring, and that equals 1/2 times spring constant times our displacement squared. So we plug in our values and we find that the person requires 2.5 joules of work to compress our spring. That is a spring constant of 2000 newton per meter, a distance or displacement of 5 centimeters. So let's go to part 2. So now, instead of compressing it, we're stretching it. And we're stretching it by a distance of 7 centimeters, or equivalently 0.07 meters. So let's say our x initial is 0, x final is 0.7 meters. So let's use our integral equation for work. So once again, we're using the integral because our force that the spring creates is non-constant. So notice we could have just simply used this equation, or we could just simply take the integral. The end result is the same exact result. So we integrate from 0 meters to 0.07 meters, our force multiplied by our infinitely small change in displacement. So we take the integral from our 0 to 0.07 position. This 0 becomes 0, and this we simply plug in our x, we plug in our k, and we get the following result. So if we want to stretch our spring by a distance of 0.07 meters, we must apply enough energy that is equal to, enough work that is equal to 4.9 joules.